seeing my screen. All right. So you're going to want to give yourself some room for this discussion, because we're going to be taking what we did yesterday, that equation for inelastic collisions, and going a step further. We're going to figure out how fast objects were going after they collided inelastically, but then we're also going to figure out what the decrease in kinetic energy is during the collision. So what I want you to have out is your notes, your calculators, and your formula sheets. Okay. So let's hop right in here. We're going to be putting quite a few formulas on here. You may already have them, but figured it won't hurt to rewrite them again, especially in this area, so you know that you can find it. So we have two clay balls that collide head-on in a perfectly inelastic collision. The first ball has a mass of 0.5 kilograms and an initial velocity of 4.0 meters per second to the right. The second ball has a mass of 0.250 kilograms and an initial velocity of 3.0 meters per second to the left. What is the decrease in kinetic energy during the collision? Okay, so we have to, first, let's write what we know. We know the masses of both clay balls. We know the velocities of both clay balls. Don't forget that the smaller massed clay ball is going to the left. Okay? So we need to figure out the overall change in kinetic energy. So we have to think about a few things first. These are what I want you to write down. Or all three of these. Okay? To calculate your change in kinetic energy, you have to take the final kinetic energy and subtract the initial kinetic energy. If you need to move up to write these down, you may do so. Okay? And so breaking these down, breaking the initial kinetic energy calculation and the final kinetic energy calculation down. The initial kinetic energy is equal to the kinetic energy of the first object plus the kinetic energy of the second object. And to break that down even further to what we talked about, oh goodness, what was it? Was it this chapter or the previous chapter? I can't remember. Maybe an earlier chapter. But the calculation or the formula for kinetic energy is 1/2 mv squared. Okay? So that's your initial. The final is going to be a little different. Okay? Because in a perfectly inelastic equation, they come together and stick together. So to calculate your final kinetic energy, you take 1/2 times the sum of the two masses multiplied by the square of the velocity. I'll know you have those written down when, because I'm going to bring something up here once you're all done. I don't want to leave the slide. So by all means, write as much of that formula down as you want. I'm going to have, I think, one last formula for you to write down. I think you're only going to need it like once, I think, in your homework. So as you're writing that down, just a reminder that your homework that you're going to get today is due tomorrow, 11:59. And your quiz is tomorrow over sections 2 and 3. And that's online. So, yes.
we not have a review?
You will not have to join Google Meet. Now, Friday is the review day. Okay? Tuesday is your test. I will have Google Meet open on Friday if you have any questions. Okay? What you're probably going to have to do is unmute yourself and say, hey, I got a question. Because I might be walking around. Okay? And I'll do my best to pay attention to it. I'll have this projected so if I'm walking around, I don't hear it, I can see it. But that way, if you have any questions. But I believe your review should have all the answers. Do that. I'm going to see if I've got the solutions somewhere so I can get those posted if I have them. But your test will also be online. Yeah, I'm not going to. You'll be in class for that, but I'm not going to make anybody get on Google Meets for those. Okay. No. Anyway, everybody got that written down? Now, before we can actually go and can calculate the change in kinetic energy, one thing we don't know. Can we point that out? What don't we know? We do not know the final velocity. So if we want to be able to try to calculate the final kinetic energy, which requires the final velocity, we have to first determine the final velocity. And so that's when we use the formula from yesterday to determine the final velocity. And then we go and solve for this. So this is what you're going to have for solving final velocity. Vf is equal to m1 v1i plus m2 v2i divided by m1 plus m2. You could, but it's the same formula from yesterday, just rearranged to solve for Vf. Okay? So it's in your notes if you decide to write that down, by all means. Okay? So we have to solve for this first. So we go ahead, plug in our values. We have a final velocity of 1.67 meters per second to the right. So we have a positive sign. So after we've calculated that, now we get to go put that information in and all the information required to solve for the initial kinetic energies and the final kinetic energies. So, again, our first clay ball had a mass of 0.5 kilograms and a velocity of 4 meters per second to the right. Don't forget to square them, or the velocity. Add that up with the kinetic energy of the second ball. And then you calculate your kinetic energy of after the collision has taken place. So you notice that there is a significant difference in those values. But we're not done yet because we now have to go back and do this part. Final kinetic energy minus the initial kinetic energy. So when we do that, we get an overall change of negative 4.07 joules. And since we have a negative sign, that is going to indicate that the kinetic energy is lost. Okay? Now, we're going to do a practice problem here in just a moment. But before we go there, you have another slide that says, write the formula here for percent decrease in kinetic energy. I'm going to give that to you here right quick. Because like I said, you're going to need it for, I think, one problem. But hey, the more the merrier. The more formulas, the merrier. So, percent decrease of kinetic energy. Okay, so basically you're going to take your KEF divided by your KEI and subtract 1 and multiply 100. Trust me, it works. Okay? So write that down. Add that to your formula sheet. Next, once you've got that written down, I want you to open up your books to a page. Oh, what page? 216. Page 216. Okie dokie. Let's see. Let me take a look and see which one I want to do. Which one do I want to do? Do I want to do? Do I want to do? How about this? Let's do number one. Okay. Number one on page 216. Then I'll give you your, you know what? I'm going to give you your homework right now. Your numbers to do. Okay. So write these numbers down. Are we ready? Number one. Number two. Number four. Number five. 1, 2, 4, 5. Huh? F. This is practice problem, or probably problem bank F. So 1, 2, 4, 5 and problem bank F. Before we get started, we're going to do a practice problem together because that's what we're going to do. All right. We're going to do number one on page 216 under practice F. A 0.25 kilogram arrow with a velocity of 12 meters per second to the west strikes and pierces the center of a 6.8 kilogram target. What is the final velocity of the combined mass, and what is the decrease in kinetic energy during the collision? Okay, so it's a two-parter, just like what we saw in our practice. So I'm going to call it part A. Okay, so the mass of our arrow, 0.25 kilogram. The velocity of our arrow initially was negative 12 meters per second because it said it's going to the west. The mass of our target that it strikes is 6.8 kilograms. And the initial velocity of our target is, we're going to assume, unless it's told us otherwise, yeah, we're going to assume it's a stationary target. It doesn't say if it's moving or stationary, but we're going to assume it's stationary. It has a initial velocity of 0 meters per second. So first thing is we need to calculate the final velocity of these two objects, okay, as they collide. So we're going to have VF is equal to M1V1I plus M2V2I divided by M1 plus M2. Now we can go ahead and plug in our values. 0.25 kilograms times negative 12 meters per second plus 6.8 kilograms times 0 meters per second divided by the sum of 0.25 plus 6.8 kilograms. So I want you to double check my work. We should get negative 0.43 meters per second, but more specifically, 0.43 meters per second west. We need to make sure this is correct because we don't want to screw up our next part. What's that? No, correct. That's what we did yesterday, but now in part B is what we're getting to do today. We all good on that answer? Okay, good. Next, in part B, it says, what is the decrease in kinetic energy during the collision? So, again, we're going to be doing changing KE is equal to KEF minus KEI. And so what I'm going to do is just I'm going to break it up like we did in the a couple slides ago. I'm going to do KEI, KEF. Okay? So this is going to be 1/2 M1V1I, sorry, don't forget square, plus 1/2 m2 v2I squared. And then KEF, 1/2 m1 plus m2 vf squared. Okay. So those are the formulas we're going to be working with here. Now I'm going to go ahead and run everything through. Key is make sure you have plenty of room when you're doing this work, ladies and gentlemen. All right, so I got, going back up to KEI, 1/2 of 0.25 kilograms times negative 12 meters per second squared plus 1/2 times M2, 6.8 kilograms times 0 meters per second squared. So when we add all those up, we should have 18 joules. Again, double check my work, please. You 18 joules? Awesome. Next, KEF. Again, 1/2 times the sum of the two masses, 0.25 plus 6.8, multiplied by the square of negative 0.43. You should get 0.65 joules. Is that right? Yep, excellent. So now, I've got my final and my initial. So I'm going to take my 0.65 joules and subtract 18 joules. I'm going to get a change in kinetic energy. Thank you, brain. Let's see, negative 17.35 joules. My brain's working right. That's correct. So, since we have a negative sign, that means we had a decrease in kinetic energy by 17.35 joules. And ta-da! We're all done with that question. Most of your questions should end with that type of, or be in that kind of format. I'm just going to give you a quick little, I think number 1 in your problem bank, that's when it asks for the percent decrease, so just keep that in mind. Okay, but everything else you should have available for you. Your problem bank has already been posted, so you've got 10 minutes. You can start working on those. And for those of you who are at home, I thank you for joining. You may go work on the problem bank. And we'll see you tomorrow.